Okay, so let's go through the last 5 questions of the practice EOC. And here's an equation or an inequality that represents some stuff that's described up here, which the words up here aren't really that important in solving the question, but they can help you go back and help with how to model number 29 if you didn't know how to build the equation. This is a more complicated version of how they built this. Right, so that should help just look for things that are similar, but maybe a little different with different things that are given, and sometimes it can help you out on the EOC. All right, so here's take a look at this one, and the first thing I should look at for an inequality, especially when I'm trying to just to graph it or label, identify which graph is correct, is first identify the graphs that are not correct, and see if you can look at the sign and eliminate things because of the sign. This is 40 is less than or equal to, that stuff, right? So if it's a less than or equal to, that equal to sign makes the line solid on the graph. If it's not there, like this, it's dotted, like that. Okay, so it's not dotted, so I can go ahead and eliminate things that are dotted. So I've already eliminated 2 wrong answers. Now all I have to do is identify the correct answer, right? So here it says that 40 is greater than this stuff. I said less than earlier. 40 is greater than this stuff. So it means that the line, right, 40 is greater than this stuff. So if I rewrite it, 6x plus 2y, that's the line. It is less, so 40 is less than that. Okay, so this, or equal to that. Okay, so this is the line, and 40 is greater than the line, right? So it's going to be in here somewhere. Now, if that is hard to conceptualize for you, just take like a point out here. Like take a point in common here and here. I used y. Let's do it so you should differentiate. Let's do this point right here. Right here. So here's a point in the shaded region. If I answered the correct one and I plug in the x value and the y value into my inequality, this should yield a false statement. If I plug it in here, it should enter a true statement. So let's take a look and see what happens when I put in y is 5 and x is 10. Right, so I'm going to do 6 times x, which I said was 10. Okay, and then plus 5 times y, which is, 2 times 5, which is y, and this should be less than or equal to 40. Okay, so let's go ahead and calculate the rest. 60 plus 10 is less than or equal to 40. So this is 70 is less than or equal to 10, right? This is 70 is less than or equal to 10. This is false, right? This is false. So right here is what shows a false output, right? That is not a true statement. Okay, so this is the correct one. Everything else is true. All right, so here I have blackberries and raspberries to make pies, right? And it says that B is blackberries and R is raspberries. And the maximum you can spend is 40 bucks. So $40 has to be greater than whatever my equation that I built in is, greater than or equal to. It can be 40 bucks, but it cannot be, that's the wrong way to sign again. It's got to be less than or equal to 40 bucks. Okay, so my blackberries is $8 a pound, so this is $8 times number of blackberries plus $9 times the number of raspberries, and that will represent the equation or the inequality, right? So this is the cost of the blackberries. This is $8 per pound per pound number of blackberries, right? And then this is $9 a pound times the number of raspberries, right? So I'm left with dollars because this is dollars per pound times pounds. So it cancels out. All I have left is dollars, right? So if I have dollars per pound, I multiply it times a pound, that cancels out. So this is my equation. 40 must be less than or equal to 8b plus 9r. You could also write it the other way. 8b plus 9r is greater than or equal to 40. Another way to look at it. Okay, so here I have some tools that we're buying, and we've got to figure out how much they're going to be after 2 years. Okay, so a table helps here. So if I, after 1 year, this is x, t, or my x value, right? This is my time. Let's not confuse that for t sub x. This is my time. My x value is time. Okay, and then the dollar amount is my y value. Okay, so it's going to look, it's an exponential function, and it's going to go down as time goes down, because it goes at 1 year it'll be 380, at 2 years it'll be 361, so it's going to be less than that at 1 year and then 2 years. 1 year and 2 years, right? Two years. Okay, so at 1 year it was worth $380. At 2 years it's worth $3.61, right? So I know that it's going to be my A, so y equals A, which is right here, times B, which is how much it's going to grow or shrink by. In this case, it's just shrink, right? Raised to the x. So I can just kind of eliminate one number already, is this 380, right? Because 380 is right here at 1. So it cannot be right here, right? So let's figure out what our B value is, right? Remember that B equals 1 minus R in this case, because it's a decay, right? So that my B value that I'm trying to calculate is this number divided by this number. So 361 divided by 380. Get a calculator. So I got my calculator. 361 divided by 380 is that. So this is 0.95. So B is 0.95. So from there, I need to make that equal to 1 minus R, because it's a decay. So from here, I'm going to solve for R, and I'm going to do move the 1 over to this side. So 1 minus 0.95 equals negative R. So this is 0.05. Therefore, R is so therefore R is equals negative R. So therefore, R equals negative 0.05. So it's going to be B equals 1 minus 0.05, which is this one right here, right? So I can also check to see if I divide 380, because this is one increment right here in my x and y. If I divide 380 by the growth, by the decay factor, so that's going to help me go up, right? So 380 divided by 0.95, and you'll see that it's 400. So that is unequivocally the correct answer. Number 44, I have a parabola. Remember, it's y equals a times x minus h, quantity squared, plus k, where this is my y value and this is my x value, my vertex. So because my vertex is at -3 and 4, right, my equation is going to be y equals a times x minus a -3 is plus 3, and then plus 4, because it's not minus k, it's just plus k. So that's my equation. I don't know a yet, but I can eliminate some of the other two. Right, so wherever I have a +3, a plus and a plus, plus and a plus, that could work. minus and a plus, that does not work. Plus and a plus, that could work. Plus and a minus, that does not work. So it's not those two. So it's either this one or this one. Now, so the only thing I really have to evaluate is A, right? So I can look at my A values and like, oh, all right, this is 1, right, because it's not shown, right? So I know that when A is positive, it is concave up. When A is negative, it's concave down, right? So A is negative when this is concave down, so it must be the one with the negative A. So right there is my correct answer. If they were both negative and I need to figure out which one was 1, say this was -1, I got to look here and see, okay, from one difference, my axis of symmetry, right, is going to go down 1 over and down 2 from the vertex, from the axis of symmetry. So that's where that 2 comes from. It's -2. Right? If it was -1, it would be kind of like this, and it would go down like that, a little bit fatter, right? But it's not. So there's that one. Okay, then finally we have the values. Let me brighten this up a little bit. The values that are equivalent. Select all the values that are equivalent to this. Okay, so let's go ahead and take a look here. Right, so let's break down. That's not a prime number, and that's not a prime number. So I can break this down. Let's look at all my perfect squares that go up to 24. So 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16. So that's going to be past that one, so it doesn't really help me with that one, but the top one. And then 5 squared is 25. So these are the 4 perfect squares that I can test to see if I can pull out of here. So I know that 24, right, is the same as, let's see, divide that by 4. So 24, if I divide it by 16, I don't get a nice integer. If I divide it by 9, if I do 24 divided by 9, I don't get a nice integer. But if I do 24 divided by 4, I get 6 times 4. And then from here, because the index is 2, right, I'm looking for the perfect square to take out. So I take that out, that is 2. So I get 2 square root of 6 for my numerator. Okay, if I gotta break this down into perfect squares, right, I can divide it by 4, right? So if I divide this by 4, it's 8 times 2, 4 times 2, 4 times 2, which is 8. So this comes out as a 2, so I get square root of 2, 2 divided by the square root of 2, right? So I effectively just took out a 4 each time, right, out of here, right? So this cancels out, and I have square root of 6 over square root of 2, which is right there. They didn't cancel it out. They didn't cancel the 2 out, but you can. They didn't cancel the 2 out, right? So, and I can go back through here, and I can double check to see if any of these are the same, right? So if I do 24 square root divided by 8 square root, it's like 1.73. It's approximately 1.73205, right? Let's divide that by the, well, let's just see if it's the same number. All right, so 3 square root, 1.73205. Okay, so that one looks like it could be the same. Okay. And then we have 1, that's not, that's going to be the inverse of that. Let's double check to make sure that the 2, let's see, square root of 6 times 2 equals that, divided by the square root of 2 equals, divided by 2 equals, okay, 808. Yep, 808. So that's the same, right? So that's useful. Square root of 6 divided by square root of 2. That's interesting. Okay, so then we have, which is, oh yeah, because this is a square root of 6 divided by a square root of 3. 6 divided by 3 is square root of, 6 divided by 2 is a square root of 3. So that is also an equivalent, right? So there's another one. And square root of 16, that's just 4, right? This is this inverted, so that won't be the same one. And then square root of, let's see, 4 square root of 6. Let's do 4 times 6 square root equals, divided by 8 square root equals, that's not it, right? Because it's going to be 4, it's going to be 2 square root of 4, which is not going to be the same, right? Let's double check that. Let's see, 4 square root of 6, no. And then this is going to be, like I said, 2 square root of 2, that's the square root of 2 over square root of 6 over square root of 2, which is not the same as that, because there's missing a 2 for that one. All right, so those are the 2 answers for that are correct in this one. Hopefully that helps you guys figure out everything there.